What's up coders? Welcome to One Little Coder. In this Applied NLP tutorial, we're going to learn about an unsupervised key phrase extraction technique. The unsupervised key phrase extraction technique that we are going to learn about today is called RAKE. RAKE stands for Rapid Keyword Extraction Algorithm. So first we are going to learn about RAKE, then we are going to use RAKE using a Python library to use it in the latest Kaggle competition to extract key phrases. So first let me start my Kaggle notebook session. While it is getting started, I'm going to explain you how RAKE works. Once again, what is RAKE? RAKE stands for Rapid Keyword Extraction Algorithm, and then we already learned that RAKE is an unsupervised technique. So by default, RAKE has got a couple of steps. So I'm going to explain it using an Excel sheet. So hope you don't mind seeing Excel sheet on a data science applied NLP tutorial. So the first step in RAKE is that you need to process your text. Am I typing? Yep. Process your text. Text processing. I'll call it text processing. Then I would call it candidate extractions, candidate phrase extraction, keywords extraction. And then we are going to talk about scoring. And then finally we are going to talk about candidate keyword scoring or candidate phrase scoring. Okay, so I would maybe you can call it 3-step or 4-step, but I'm going to call it 4-step, and we're going to see all these steps in detail. So first we need input text. After we have that, we are going to do text processing. Let me take an input text for example. So let me say Excel is an amazing tool for data science, but a lot of data science professionals do not like Excel. Okay, so let's say this is the text that I've got and I want to use RAKE. I'm going to learn how to use RAKE. So the first step is we are going to do tokenization. So tokenization happens using the separator, tokenization happens using stop words, tokenization happens using the punctuation marks. So here I'm just simply assuming that anything that is, that has space, I'm going to tokenize. I'm going to use the function from Excel called split, and I'm going to say tokenize it. So this is how my tokenized letter looks like. We're going to eliminate this dot later on, but this is how it looks like. So I'm going to paste the values here, and after I paste the values here, I'm going to open a new sheet. I'm going to transpose it and then paste it. So transpose it and paste it. Okay, at this point I've got the list of words. I've got the list of words from the given text that I've got. So now I'm going to find the stop words and I'm going to eliminate them. Okay, so is this a stop word? Yes, this is a stop word. This is a stop word. This is a stop word, and maybe we don't need dots. I'm going to remove dot, and this is a stop word. This is a stop word. I think a lot is also probably stop word, and do probably, I don't know, do is stop word, do not could be stop word. So I'm going to just put stop. Like might be stop word, but I'm not sure. I'm going to just leave it as it is, and I'm going to remove Excel. Okay, the dot. So at this point we have clarified that we have got a bunch of stop words. So let's say we want to remove the stop words. So I'm going to use this and I'm going to filter them. I'm going to go to data, create filter, and then say give me all the stop words. Right, I'm going to make it show only the stop words, and I'm going to give a very nice red color for these stop words, and then so that you can see when I remove all these things, you can see basically we don't want stop words and we have all the other words here. So we are going to use everything other than the stop words, right? We are going to use everything other than the stop words, which means Excel is an amazing tool is what we are going to use. I'm going to open a new sheet. I'm going to paste it here. So Excel, amazing tool, data science professionals like Excel. So this is how it is. But one thing that you need to note down is when we go back here, I would like to quickly show you that the way now we are going to get the candidate phrases is that I'm going to transpose this and paste it, transpose, okay, and I'm going to reduce the size. So the way we are going to use this is wherever there is a stop word, for example, wherever there is a stop word, now that is considered to be like a word boundary, which means now this is a single phrase, but this is another phrase, this is another phrase, this is another phrase. So this is how it works. So you have got one word here, this is a single word, but here you have got two words, here you have got two words, here you have got three words, and so on. So that's how the candidate phrases are created. So having said that, so what are our candidate phrases? We know Excel is our candidate phrase, amazing tool is a candidate phrase, then we have got data science is a candidate phrase, then we have got data science professionals is a candidate phrase, and then we have got like Excel is another candidate phrase. Okay, so we got 4 candidate phrases, and I'm going to copy it and paste it in my new sheet. So I've got 4 candidate phrases. The first thing that we are going to do now is we are going to count the number of words. So 1 1 1 1 1 1 1 1 1 1. So now I'm going to use Excel pivot to just count all the words, which means I'm going to insert a pivot table. I'll insert it just here, existing sheet just here, and I'm going to say this is where I'm going to add my rows. My rows is like Excel. Excel has become, unfortunately, my title, so I'm going to add a new row saying word and score. Okay, I'm going to say now once again I'm going to add the pivot, right? I'm going to say Excel is my first row. My first row should be a word, and inside these words you can see all the words, and I'm going to add the values, the score I'm going to sum. And as you can see, amazing has appeared one time, data has appeared twice, Excel has appeared twice, professional has appeared once, like has appeared once, science have appeared twice, and tool has appeared once. So this is our final score. So for RAKE you need 3 metrics. What are the 3 metrics? One, you need word frequency, right? The second thing, you need degree of word, and third, you need degree score. So you can call it degree as well, like degree. So you're going to use this. So basically your degree score is, let me say, degree of word divided by word frequency. So far what we have managed to calculate is we have managed to calculate the score. So I'm going to copy this, right? I'm going to copy this and add a new column to the left, and I'm going to paste it here. I'm going to paste values only. So this is my word frequency. So at this point we have successfully managed to get the word frequency. Now what is degree of freedom? Degree of freedom, did I say degree of freedom? I'm sorry. What is degree of word? This is identifying how many times the word co-occurred. So if I've got a word, we can see how many times a particular word co-occurs with another word. So which means we need to create like a matrix. I'm going to put this matrix here, right? I'm going to copy this and paste the words here, and I'm going to paste the transposed words here. Okay, I'm going to paste the transposed words here. After we have got the transposed words here, let me just for the sake of formatting, I'm going to put here. Okay, so at this point each row represents how many times the particular word has co-occurred. So how many times amazing has come with amazing? Of course, once. Okay, how many times data has come with data? You can say 1. And how many times Excel has come with Excel? 1. Like has come with like 1. Professionals have come with professionals 1. Science tool 1. Okay, so I'm going to use it like this, like all these things have occurred once. Okay, no, I think I made a mistake here. So data has occurred with data twice, Excel has occurred with Excel twice, professionals once, science twice. Okay, so this is how it should be. Excel twice, so this is how it should be, right? So amazing once, data twice, Excel twice, like, so this is fine. But has data ever occurred with amazing? If you see here, no, I don't see it, so 0. Excel appeared with amazing, no, 0. Like appeared with Excel, 1. Professionals appeared with Excel, 0. Science appeared with Excel, 0. Tool appeared with Excel, 0. So the same way I'm going to now find for amazing and data, and I will say data appeared with amazing, no. So this is what I'm looking at now. 0 and Excel 0, like 0, professionals 0, professionals and data once, and science once, Okay, I think in fact science and data have appeared twice, right? Twice. And tool 0. Let me do this quickly. Excel where Excel and amazing 0, Excel and data 0, Excel and like once, Excel and professional 0, Excel and science 0, Excel and tool 0. And next like 0, 0, 0, 0, 0, 0. I think with Excel it came once. Next professionals 0, 0, 0. We got it with data once, right? And then we got once with science and then 0. And then if you look at science appeared twice, once with twice with data, 0 with like, 0 with like, once with professionals and twice with science and then 0. And then finally we have got tool has appeared once with amazing. So once with amazing, everything else is going to be 0. So now at this point we have successfully got the degree matrix. I would call it a degree matrix or a word degree matrix. So now we are going to calculate the sum of all these. Okay, so we have to calculate sum of all these. So we have got sum of all the words. So we have got the words, right? We have got the words and we have got their sum, right? At this point we have got their sum. I'm going to take the values only, and you know this is the order in which we have got here. So I'm going to just copy these values, just these values, and then I'm going to paste transpose here. So at this point we have got the word frequency and then we have got the degree of word. So calculating degree score is this divided by this. Okay, autofill. So we have got degree score, we have got each value we have successfully got. So now what we are going to do now is, we already know what are the phrases that we have got, right? We have got the phrases and we have got individual score. Now all we are going to do now is, we are going to calculate the cumulative score. For example, you know, for Excel is only one value. Excel is 1.5. Okay, Excel is 1.5. Cool. The next is amazing tool. Amazing is 2.5 and tool is 2. So you have got 4.5. What do we have next? We have data science. Data is 2.5 and science is 2.5. So we have got 5. And then we have data science professional. 5 plus professional is 3, 8. This is 8. Like Excel is 3.5. So now this is how it is rated. Now we are going to sort this. We're simply going to sort this and then say sort range by column K. So we have got, I think I sorted it by column K. I should have sorted it by column L. So I'm sorry. Sort it by column L. Sort it in descending order, please. Okay, so sort it in descending order. I have to say sorted by descending order. Yeah. So data science professional is the most relevant topic for this, the phrase. Data science is the next. Amazing tool, like Excel and Excel. So now this is how RAKE is going to calculate the key phrases that you get from a given text, and then you are going to rank it. So that's what this algorithm is actually doing. So this is the output that you're going to get when you use RAKE. So you're going to get the key phrase and then you're going to use the score to evaluate the key phrase. So I have used RAKE as a topic extraction algorithm. A lot of times in NLP, people like to do topic modeling, but I would say that topic extraction is quite helpful in a lot of contexts. For example, you're exploring survey data, or you're exploring reviews, app reviews, or some kind of reviews. Now you want to know first, before even you move into topic modeling, you want to know first what are the things that people are writing about. Usually what people do, they build unigram, they build bigram, they build trigram, they do all these kind of things. But what we can do is we can use a topic extraction algorithm like RAKE, which is an unsupervised topic extraction algorithm. Independent of the language this works, and we can see what kind of topics people have talked about in the given text corpus. So I hope the concept of RAKE is clear. If you have any comments on this particular aspect, please let me know. But now we are going to move into implementing RAKE, or we're not implementing RAKE, we're going to use RAKE in a text. So we have got a Kaggle competition that's currently going on. So this competition is about, I think, identify key phrases in patient notes in medical licensing exams. So if you look at the data set, you have got a data set which has got a patient notes. So there is a column in this that talks about the notes the test taker has recorded. Okay. So now we are going to first look at how to do this. I hope the session has started. Let me check quickly. 2 + 2. Oh, the session is still not started. I have to quickly restart this notebook. Maybe I'll refresh this. This notebook would be available for you as let me edit this. Yeah, let me edit this. This notebook would be available for you in the YouTube description. So if you want to use this notebook for this competition or something else, all you have to do is simply go to the link and then click copy edit. This should be ideally available for you. Okay, so this notebook is up and running at this point. This is just for my verification. So what we are going to do now is we are going to simply import numpy and pandas, which we don't need. Pandas we need for reading the input file. To read the input file, I'm going to just look at a corpus, a text corpus. So Mr. Cleveland is a 17-year-old male with no significant blah blah blah, and then you've got a bunch of text. So now we're going to try RAKE. The reason why I've given RAKE is because there are two different RAKE implementation. In fact, there are a lot of different RAKE implementations. I'm using one of the implementation. I'm not going to go through the second one, just the first one, just for anybody who's looking at the notebook to compare. I've got the second implementation as well. So the library name is called RAKE NLTK. First, I'm installing the library. Let me check if the library is already there. No. So I'm installing RAKE NLTK. So as you can see, I'm installing RAKE NLTK. After I installed RAKE NLTK, I'm going to import RAKE. So after I import RAKE, then I have to create an object. Okay, so now this is done. Ignore the error, but it's installed. So I'm going to import it. After I import this, now I have to define RAKE. So the way you can define RAKE is you can use any object name and then you can give it like this. So when you do this, it's not going to ignore any punctuations. Okay, so first let me show you what happens with this, then we can show you with punctuations. So let's say we have created an object RAKE. Now we know this is our text, this text, right? I'm going to give the entire text inside this function or this function called extract keywords from text. Okay, now at this point keyword extraction is happening and keyword extraction is done. Now after keyword extraction is done, now all we have to do is we have to say r.get ranked phrases. If you just want ranked phrases, you can get the phrases like this. But if you want ranked phrases with score, you can say get ranked phrases with scores. And then you get score and then you get the phrase. So the way you get it is like a tuple for each phrase. It's a tuple and then you get a list of tuples. So what I've done is I've taken the list of tuples and I've put it inside data frame and then I've given the column name score and phrase. So now I'm creating a new data frame called phrase df, and you can see phrase df. This is how it looks. We don't want, there's something that has just one score. So I'm using a threshold to say, give me anything that has score greater than 3, right? And when I do that, you can see that I've got about 29 topics that has got score greater than 3. Well and good. But now when you look at the topics, you see the close bracket, you see comma, you see dot. I mean, these are not desirable. You can do text processing separately, use NLTK, use text blob, anything, use text blob, and then you can do it. Or on the other hand, while you are initializing this RAKE object, you can say these are the punctuation marks I don't want. You can actually specify that these are the punctuation marks I don't want, and you can use that like a sentence boundary or something, and then you can run this. And now when we run this back, you can see that those things have got eliminated. So those brackets that we had, and it's eliminated. So you can see some certain symbols or punctuations are there, but if you want to eliminate these as well, you can add it there. So this is how you do RAKE, and then ultimately you have like the topics. You can now see, okay, sexually active with girlfriend, use friends, I don't know what is it, prescription medications. So maybe though is not classified as a stop word, you can give stop words. So you can do all these things and then you can get the topic. And this is completely unsupervised and works works well for any language. It has got its own limitation. For example, if you have got a word like, good day, then it would automatically assume these two are two different words, but we know that it's not two different words. It has got its own limitation, but I have fairly been successful in using RAKE in my professional career, especially when I dealt with natural language data like reviews. And I hope you also find it useful when you use RAKE in your work, NLP pipeline or work. If you have any questions, please let me know in the comment section. Otherwise, I hope this video was helpful to you in understanding what is RAKE, how it works, how does it happen manually, and then also using the RAKE NLTK library to implement RAKE on Kaggle competition dataset. Like I said, this notebook would be available in the YouTube description. You can just directly go click, copy, edit, and then start using it. Thank you so much for watching me. Have a nice day. Happy coding and peace.